In this video, we are going to cover fuzzing using Python script. Python can be very useful to spinning up a quick script to repeatedly connect to a service and send in different amounts of input. First, let's run vulnerable server. Make sure that it runs as administrator. OK. Waiting for client connections. Now let's attach it to Immunity Debugger. File, attach, and find the Van server process. Now the app is running inside the debugger. Make sure that it is not paused by pressing the play button here. Now let's make our fuzzer in Python. Open the terminal. Type nano anything, for example fuzz.py, which is the extension of Python. You can use Vim or text editor. Here I choose nano to create the script. Hash exclamation mark slash user slash bin slash Python, which is the path of the Python executable. If you are following along, make sure that you type this out. Import sys socket. We will need these modules to interact with the Python runtime environment and network. From time, import sleep. We use that because we will use the sleep function to wait for some time between every request. Declare a variable, for example, let's call it buffer. And inside it we will put 100a. As you can see, it is a times 100. After that we will use while true because we want to go into a loop. We will use try to try something because we want to try to connect to the server, then send something. Then we will create a socket by writing the following line: s equal socket.socket. The first parameter is af underscore inet. And the second one is sock underscore stream. af underscore inet refers to the address family IP version 4. And the sock underscore stream means connection oriented TCP protocol. After that we will use the connect function to connect to the server through the IP version 4 address and the port, which is 9999 because I am using the default port of Van server. Now imagine that we are connected to the server. Let's send something. We will send the command plus amount of characters. Remember, we used spiking and found that trunc command was vulnerable. So we will send the trunc command with this extra information here, because this is how Van server works. It was something sent to the server after the command and we noticed it in the Immunity Debugger. Then s.close to close the socket or the connection. After that, sleep for 1 second to wait for 1 second before every request. Then buffer equal buffer plus a times 100 to append 100 A's every time. So we will keep sending characters and the amount of A's will be bigger every time. The first time will be 100, then 200, then 300, and so on until we get a crash. We also want to try to detect where it is breaking and at what specific byte size. So we will put an exception to do something if there is a crash. For example, we will print the prog crashed at and put the length of the current buffer. By using the len function, we can return an integer of the current buffer length, then convert it to string using the str function. After that, exit from the script using the sys.exit function. Press Ctrl X, then Y to save, then Enter to exit. Now our Python script is ready to fuzz one server. Make sure that one server is running. Okay, one server is running. I will make one server and Kali Linux in the same window together so you can see what will happen after executing the script. And before we execute the script, make sure that you give it the executable permissions. chmod +x fuzz.py. Now let's execute the script and see what will happen. As you can see here, the server is receiving connections from our script. You can see that it is still running here. Our script now is sending a lot of A's to try to make it crash. Here we go. Now it's paused. One server has been crashed. You will notice a lot of A's in the immunity debugger. Go back to Kali Linux and hit Ctrl+C and you will find that one server crashed at somewhere around 3100. Okay, let's go back to immunity debugger to see the crash. As you can see, there is a bunch of A's sitting here. It seemed that we didn't route over the EIB. It's okay. We just need to know where we crashed at. Our script told us that we crashed somewhere around 3000 bytes. In the next video, we are going to find where the EIB is at. We will use a tool that is going to create some values that we are gonna send out to check what is the EIB value and at which number of bytes that we sent over. The most important thing is to control the EIB. Once we control this register, we will be able to point it to our malicious code.